right, so when we left it off on Wednesday, we were going through this car loan program where you take out a car loan for a certain number of years, say 5 years, at a certain percentage rate, in this case 5%, meaning that you're going to be paying it monthly, 60 payments, 12 months in a year, over the next 5 years. You borrowed $10,000, and so the monthly payment is given by this this formula right here. We were successful in pulling in the principal, the annual rate, the years, and therefore we could calculate the months. And then we were able to calculate the monthly rate, which is just the annual rate divided by 12 months in a year. And finally, we were able to create the monthly payment. And it came out to $188.71, but we were having trouble getting that actual amount there, right? Initially, we thought it was 71 cents and then some, fractions of a cent. And our first attempt at solving that was to bring in the round function. We're going to round it to the nearest cent is what we want, but it ended up being rounding to the nearest dollar, right? So let's remind ourselves of the input here, GCC demo.c. Remember, always have the wall flag from now on. And if you're going to be doing math stuff like rounding then, or POW or anything else like that, you need the -lm flag. Let me go ahead and run this. Remember that we were checking for command line arguments here. We were checking that there were 3, principal, annual rate, and the number of years. And that adds up to 4. Why was that 4? What's the first one? A dot out. Right, so if there are not 4 command line arguments, then we get this error message right here. Otherwise, $10,000 at 5%, it's on the scale of 0 to 1, for 5 years, that's $189 for my monthly rate. Now, certainly that'll work because we're paying more than we need to, but it is not correct. It's not $188.71. And that is because round, if we read about it, or if we asked the duck debugger here, it would tell us that round is actually going to the nearest whole number, which it makes sense because that's what rounding is. I want to not round to the nearest whole number. I want to round to the nearest cent. $188.71, say, 4 cents, a fraction of a 4 there. I want that to become $188.71. Okay? So, ideas on how to get that. Yeah, go ahead. Sure. Yeah, well, times it by 10 if you want the nearest 100ths.
No, so on the round statement, it's times it by 10, so usually you want to put the decimal one, and then you divide it by 10.
All right, so 10 would only round to the nearest tenths, right?
That would be for 1, or if you want 2, then it'd be 100.
Yeah, there you go. And we want it to round it to the nearest cent. So the idea there that he's expressing is, what if we were to change that period there? What if we were to move it over to 2 spaces, and then we were to round it? Now, rounding it would get us 188.71.0 now, right? But that's still not correct because, monthly, you're not paying $18,000, right? So we want that to go back to 188.71 after we've rounded. So that ends up being 0 at the end, right? So the idea there is that we're going to multiply it by 100, right? There we go. And then once we're done, we divide it by 100. All you're doing is you're floating the decimal place over. That's why we call them floating point numbers. They float over, right? And so we're floating it over by 2 spaces, and then we're floating it back by 2 spaces. We're taking it from here and putting it back to here, right? That means that we didn't have to write our own round function, right? We were able to reuse an off-the-shelf solution by just simply changing the input and then massaging the output that we were given. All right, I'm going to go ahead and get rid of all that. Do I have to go .0, by the way? No, because there's no integer truncation here because monthly payment is double. All right, good. So let's go ahead and recompile this. And now let's see if we get the monthly payment correct. Yes. Yeah.
And so you also don't have to round it because 100 is not something it's not a variable that you have to declare this integer.
Well, right. This is just a scalar. This is just a literal value. This doesn't change monthly payment. This just multiplies monthly payment by 100, takes that result, monthly payment is still over here, takes that result, hands it off to the round function. The round function then gives us another result back, and then we divide that by 100. We never actually touched this variable until we got that final result, and then we put it back in. Now, we do not print money out to multiple decimal places. We only print it to 2 decimal places for US dollars. And so how do I limit it to 2 decimal places? 0.2. And if we do that, then great. Now we've got our monthly payment. All we need to do now is produce this table. Right? No more formulas are needed here. I want the month, the balance, the interest, and then the new balance after you've paid it down. Just to review, initially you have $10,000 that you owe. You're going in that first month, you're going to pay $188.71. However, $41.67 of it goes to interest. Only $147.04 goes to the principal, paying it down to $9,852 and change. All right? So I'm going to need some sort of a loop here because I'm going to do it for the first month, the second month, the third month, et cetera, et cetera. What kind of a loop do you want to do? A for loop. Why did you immediately run to a for loop? You know exactly how long it takes to pay off the loan, right? The number of months. So what I'm going to do is I'm going to create a for loop, for int. I could call it I, but it actually, in this case, it represents the month, right? Not months, because I already have that variable on line 23, but 1 month. I'll start it at 1 because the first month is month number 1. Month is less than or equal to months, right? We're going to go all the way up to the 60th month, and then plus plus. One argument against using month and using I instead is because you might confuse month with months, right? So I would argue, yeah, it's okay to use I here. Right? If you want to use month, fine, but if you don't want to confuse yourself between month and I, then go ahead and do it this. First of all, we need our header, and I just cut and pasted from the handout there, right? It's not going to look pretty, it's not going to look aligned, but we can fix that later on. All right, what I want to do is I want to print out 4 things: the month, the balance, the interest, and then the new balance resulting in the next month there. All right, so printf, well, the month is going to be %D. The rest of them are dollars, right? So the dollars, and dollars. I guess I'm printing out 5 things, right? Balance, interest, new month, balance, interest. Oh, there should be principal in there too. Principal. All right, there we go. So I'm printing 5 things there. And they're all going to be dollars, right? So let me go ahead and give myself room here, 0.2f, right? And put a $ in front of it. And then, and then the next one, then the next one. It's putting in periods there because I'm doing double space. So it thinks I'm trying to write like a sentence. But yeah, come on, I'm not trying to write a sentence. There you go. All right. I'm going to need all of those things. The first one, of course, is pretty straightforward. It's going to be I, the month. Right? Now, right now, it's not going to print out anything. Right? In fact, it's going to be a bunch of warnings. Right? But at least I get my 60 months there. Right? All the way to the top here, 1 month, all the way down to 60 months because it's a 5-year loan. All right? All right, so now we need to figure out each one of these things. Here's the old balance. Then we need to compute how much interest there is. And then we need to compute how much of the payment goes to, well, we already computed the interest, how much of the remaining payment goes to the actual pay down of the loan here. So let's go ahead and focus on this one first. I want to know how much interest I'm being charged that month. All right, that's just going to simply be, how did I get that $41 or whatever, $41.67? Let's go to Wolfram Alpha because I like using a calculator here, right? Remember that in the first month, we owe $10,000. And we took a loan out for 5% interest, but it's only 1 month. So what is the monthly rate? Divide that by 12. Right? And that's where we get $41.67. But remember, it's $41.66666666 repeated. How would I have gotten 67 out of that? Same trick as before. Round to the nearest cent. So let's go ahead and codify that. Literally codify that by writing code for it. Double interest is going to be equal to the current balance times the monthly interest. What was it? Monthly. I guess what did I call it? I did put in monthly rate here, so I can go ahead and go monthly rate. All I'm doing is reusing that variable up here instead of 0.05 divided by 12. What I did is I put that into a variable, right? And let's go ahead and grab that monthly rate. There we go. Now, if I were to print that out right now, you would see that it's $41.66666666. So what should I do with that value there? Same trick, rounding it, but multiply by 100 to shift that decimal over, and then divide by 100 to shift it back. All right, there's my interest. Double principal payment is going to be equal to, all it is $188.71 minus this guy right here, giving me the remainder. So it's monthly payment minus the interest that we just paid. Right? So I've got my interest payment. Let's see. I've got my balance, of course. I've got my interest payment. I've got my principal payment, and then I've got the new balance. So let's go ahead and put those in there. Well, first of all, do I actually have a variable called balance here? If I were to try to compile this right now, it would say I have no idea. After warning, 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 it'd be the error. What's balance? I see no balance here. Right? Originally, this is called principal. So these are terms of art for loan officers or financial people. The principal is the original or loan origination amount. That's the amount that you originally borrowed. But the balance is how much you still owe on it. So let's go ahead and create and distinguish those two variables. There is a difference between the original principal amount and the balance. But initially, before everything starts, the balance is equal to the principal. Okay? All right, now I've got that variable, and I'm still going to get a whole bunch of warnings here. For now, what I'm going to do is I'm going to go W and LM. There we go. That flag right there actually suppresses all warnings. So don't use it. I'm just using it right now to get rid of them so that we can concentrate on other things, right? Always use the wall flag, all right, so if I were to run this right now, of course, it's not going to, here. It's not going to print anything out because I'm not actually printing out all this stuff out. So let's do it. I'm going to print out the balance. There we go. I'm going to print out the interest and the principal and then the new balance. Right? But I don't have new balance yet. So what I'm going to do is I'm going to leave that off for now. I just want to make sure, am I at least doing it in that first month correctly? Let's find out. Here, all right. Clear everything so I can scroll all the way up. There we go. All right, well, that's garbage there because this is not being printed, but this is what I want to pay attention to here. Is it correct? 4167 and 147.04. Yes, it is. All right, great. Now I need to figure out my new balance here. Okay. Well, what's my new balance? Do I really need a new variable? New balance is going to be the old balance minus the principal payment. Actually, I shouldn't even call this principal, right? Because I'm already using that variable up here. Let's think of a better variable name. Principal, monthly principal? Monthly principal? There, that's a lot better. Right? And monthly principal, there we go. All right, so the old balance minus the principal, that'll be my new balance. But do I really need these two new variables? If I've got the old balance right here and I've already printed it out, or we'll get it, we'll fix that eventually too. It'll lead to another problem. But I've got $10,000 here. You pay it down by 147.04. This should get updated right here. This balance right here. So let me go ahead and update that. The new balance is just this balance, which is the old balance minus the monthly principal. Sorry, monthly principal. Okay. Let's go ahead and see if this works now, and I'm going to put the balance over here. Balance. Before I run this, do you think this is going to work if I try to print out balance twice? Let's find out what it looks like. All right. And oh, by the way, let me restore the wall flag now because I've taken care of all the warnings. I believe I have. Yep, there we have. Great. So let's run this one more time, and it looks a lot better. But let's see. Whoa, I got a free payment or something, right? Started out at 10,000, and then I printed it over here. Well, that's because I'm printing the same variable here, right? So maybe I do need another variable here, right? So I could create a new balance, double new balance. There we go. Is equal to the balance, and then I'm not actually changing the balance. I'm printing two different things here. Let's run this really, clear this out, run it, and jump up here. That looks a lot better for the first line. 10,000, these two numbers were still correct and they're still the same. And then 9,852. But for some reason in the second month, they increased my balance back. It's like I didn't make that payment. Right? I'm never updating the balance, am I? Right? Yeah, I think If you, by the way, here's another IDE tip, excuse me, that if you hold down the command button on a Mac, I think it's probably Control on Windows, and hover over a variable, you can actually click on it and it'll take you to where you declared it. And then you can follow that all the way down. Like, okay, there's an instance of balance. Where else is, okay, it's not highlighting. Some of them do. But let's see. I think that's the only other instance of balance there. Right? Okay. So it looks like I'm never actually changing balance. Right? I create it, right? And then it never gets changed, and that's why I always owe $10,000 throughout the entire thing. I never paid it down. Right? So what do I need to do? I need to update the balance. Right? The new balance for the next month becomes the regular old balance. Right? This number on month 1 then becomes the new balance on month 2. The new balance on month 2 becomes the actual balance for month 3, and so forth. I need to carry that forward. And to do that, I'm going to say the balance is now equal to the new balance. Careful, is that where I should do it?
No, it should be after your printf statement.
Yeah, after I'm done with everything, right? After I've printed it, to set myself up for the next iteration. Because if I do this, let's see. Oh, whoa.
The only thing that's wrong should be your first line.
Okay, yeah, there we go. Now it's just the first line that's wrong right here. Thank you. But I'm going to go ahead and move that down to after I've printed out everything. And this should actually fix everything now. Let's clear everything out, recompile it, and run it one more time, and then run up all the way to the top. 10,000, 4167, et cetera, et cetera. Let me go ahead and shunt that up. That looks all good all the way through month 6, after which I don't have any examples. In fact, yeah, everything looks good now. Right. But that ellipse there is just because, you know, I didn't want to put all 60 things in the notes. All 60 months in the note. All right. Anything else that we could do with this? We could figure out the total cost of the loan. For example, at the end, how much interest did we actually pay? We borrowed $10,000, we paid $10,000 back, but we also paid a bunch of money in interest. So what's the total interest here? Printf, total interest paid, be percent D, dollar sign, percent 0.2f, and then end line. What's the total interest? Interest, there we go. I need that as a variable. Before I start everything, what I'll do is I'll create it up here, and I'll initialize it to what? 0. If I don't initialize it to 0, you're throwing the die, right? You're throwing the dice on what value is in there, because there is no default value. Let me see if I can manifest a bug here by not doing that. Jets or something? Are they having a flyover for the game tomorrow? And they're practicing? Right. Okay. Yeah.
Is it always good practice to always, initialize everything?
Always initialize a variable. Yeah, and we'll see. Hopefully, it'll show up here on why that's a bad practice not to. But all I'm going to do is, on each iteration of this, once I've computed the interest, I will add that interest to the total interest. Is there a more compact way of writing that? Yes. Plus equals interest. And then at the end, we print it all out. GCC, run it one more time, and it looks like $1,322.74. Right? So we got away with it. I think we got away with it by not initializing this. But I'll go ahead and initialize it and see. That's $1,322.74. $1,322.74, so we got away with it. It's that one time out of 100 that you're not going to get away with it, and you're going to have garbage results. All right. So let's put this in the notes so you have it if you really want it. Otherwise, there is another version of this on the pre-prepared videos, I think. And those are the only 2 exercises I had here, but we've got plenty of time, so I'm going to pull out my textbook. There we go. And we've got another couple of dozen exercises here if you want. Right? The first one I decided to do today is called the rainfall problem. So before the FizzBuzz problem came up, remember that one that we did last time? That's used on, I don't know that it's used on interviews anymore since it's so popular now. or everybody knows what it is, right? So now you can do your interview prep on it. This one used to be used before FizzBuzz. It's called the rainfall problem. So implement a program to do the following. What it's going to do is it's going to prompt the user for input that represents the number of inches or centimeters or whatever of rainfall on that day, right? Until the user enters in 99999, right? 5 nines. After 9999 is entered, it should print out the correct average rainfall, right? That is, it should not count that final 999. And also, if you ever enter negative values, can it rain negatively? That's called evaporation, I guess, but that's not how we call it, right? But it could be that you don't have any rain, like it didn't rain today, right? So sometimes you could have 4 inches of rain, which is torrential. Then it didn't rain at all. Then they had bad user input, which we'll ignore. Then it rained to 10 inches, right? So maybe these are milliliters instead, right? And then finally they entered 99999. That stopped the program. Then we report that the average rainfall is 4.66. Where do we get that number? 4, 0, and 10 are the only valid values. So there's a total of 14 inches or 14 milliliters or whatever, divided by the number of days. 1, 2, 3 days. Right? We don't count negative values here. And so 14 divided by 3 gives us 4.66. Right? Question? No? Okay. So let's go ahead and do this. I already copy pasted this, so I'll go ahead and get rid of all that. All right, so I need to prompt the user for the daily rainfall that day. So double daily rainfall, right? Okay, and you can initialize the variable here. It could be 0. Right? There we go. And I'll prompt the user for that input. Printf, enter the daily rainfall, right? And the line. And then how do I read it in interactively? Scanf. What is my placeholder for a floating point number in scanf? %LF, long float. And then I will read it into my daily rainfall variable right here. I'm just doing this for the first day. What am I gonna face if I try to compile this right now? I'm going to get a warning that there's something wrong with daily rainfall. What is it? Ampersand. Magic for now. Remember. You just have to put the ampersand. If you're going to use scanf, you're going to put the ampersand in front of it for now. We'll talk about that later when we do pass by reference and pointers. Right? Okay. All right, and then that's the daily rainfall. I'll also want to keep track of a total, right? Double total rainfall, fall, and I should definitely initialize this to 0 before I get started. Once you've read in the daily rainfall, I'll say total rainfall, fall, plus equals that daily rainfall. But that's only if it's a valid value. If it's 4 or 0 or 10, if it's negative, what should I do? Ignore it. Right? So if the daily rainfall is greater than 0, then I will add it to my total. What's another condition here? Yeah, if it's 9999999 or 5 nines, right? Then if daily rainfall is 99999, there we go. Make sure that I got that correct. Then end this loop. I haven't written a loop yet, so I'm just going to keep that in mind there as pseudocode. And then I'm going to have an else if now. Else if. Right? Then I'll put another note in here. Repeat. Above. Right? I'm going to go back up. If they entered 5 or 4 or 0, I'm going to go back up to the top, or even negative. I'm going to go back up to the top. Okay? All right. Now let's surround this entire procedure here in a loop. What kind of a loop do you want? Yeah, why a while loop? Well, in this example, they gave 4 valid inputs, and then they did 99999. Right? In another run, they could give 10 valid inputs. In another run, they could do 20, or they could do 1, right? Or they could do 0. So be careful of that too. That is a possibility. So I'm going to do this as a while loop. While some condition, I will prompt for input, read the input, and then check to see if that input is valid. Okay? All right, so end this loop. All right. Well, all right, that needs to be incorporated up here, not down here as an if statement, right? So, while the daily rainfall is not equal to 99999. Oops, there we go. Why? Because if it's equal to 99999, I want to end this loop. So while it's not equal to 99999, I want to continue this loop. All right? So the daily rainfall is not 9999, so I'm going to take that out now because it's incorporated in my loop. All right, there we go. All right. If it is positive, I add it. Otherwise, I will ignore it. And that repeat above is automatic because I'm at the end of the while loop here. All right. Let's assume that this works, and let's print out the average rainfall here. I don't like typing, so I'm going to steal that. Printf, average typing, %f, and the line. And this is going to be not the total rainfall, but the average rainfall, which is the total rainfall divided by number of days. But was I ever tracking the number of days? Nope. So let's go ahead and create that variable now. Right? Int number of days. How many days have I seen so far before anything begins? 0. If you add it up to the total, what happens? Number of days increments by 1. Right? If it's negative, actually, is this even correct now?
That is not. That needs to be equal to or greater.
Greater than or equal to 0, right? Because if it's 0, that's perfectly fine. They just didn't have any rain that day, right? But it's still a day, and yet it's still an average day, right? You need to include that in your average. All right, so let's go ahead and run this and see if it works. All I'm going to do, initially I'm going to copy that input. So I'm going to go 4, 0, negative 1, 10, and then 99999 because I know what the output should be down here, right? So let me put this off to the side here so I can see it because I'm never going to remember that. Or I guess I could just cut and paste it over here. We saw a lot of people do this in their hacks. The 3 test cases or whatever that you have to write. They would put it in their hacks in a comment. We noted that that's cruft, take it out, don't do that, but we didn't take off points for it, but we will in the future. So I'm just putting this here for now to remind myself of what it looks like so I don't have to flip the page over anymore. So it's going to be 4, right? 0, negative 1, 10, and then 1, 2, 1, 2, 3. There we go. Ugh, wrong. So first of all, it's huge. What do you think it's doing? It's probably counting that value right there, right? So what I could do, I could cheat, and what I could do is I could say, oh, I counted that value, therefore what I must do is total rainfall minus equals 99999, right? And that will probably work. It's just a lot of typing here. What is it? 4, 0, negative 1, 10. I screwed up already. All right. 4, 0, negative 1, 10, and then 1, 2, 3, 4, 5. There we go. Still wrong, though. I mean, it's closer. Yeah, it's closer. But is it close enough? No. Right? At this point, I would encourage you to, again, use that tool that I described before, pythontutor.com/c. And what you can do, eventually we're going to talk about proper debuggers. But what you can, you know what? I don't even know if I can use this here. I don't think that there is interactive input. Visualize this execution, and it's not going to work, darn it. Because there's no way that I can get to scanf. Yeah. Darn it. All right, that's not going to work. Instead, I'll show you another way. It's called poor man's debugging. Okay? Poor man's debugging involves adding a superfluous print statement here. I'm going to add a print statement and print out what's the total rainfall after this. So total rainfall is equal to %f, and then number of days is equal to %d, and I'll end the line. In other words, I'm going to print out the variable values every single time on every single iteration of this, right? And this is totally common for people just starting out, right? That's why we call it poor man's debugging, because you can't afford a proper debugger yet. We haven't covered it, but we will, right? And let's go ahead and run it again. All right. So the total rainfall is now 4, number of days is 1. That's correct, right? All right, good. So next one would be 0. I would expect it to stay at 4, but the number of days will now be 2. All right. Okay. -1. Now the rainfall should stay the same, and the number of days should stay the same because this is invalid, right? Okay, that works. 10. So it becomes 14, and the number of days is 3. Right? Okay. 99999. Right. Total rainfall. Okay. Well, that's kind of weird because it added that, and then there's the other one. Even though we subtracted this off to fix it, what didn't we fix? The number of days. So I could, again, number of days, correct for that by going minus minus. Right? And let's see if that works now. I hate typing, but echo 4 0 -1 10 1 2 3 4 5 into a dot out. There. All I was doing was saving myself some typing there. That's a Unix trick. Echo, all it does is it simulates typing. Somebody typed the shell will type it out for me. And then it pipes it in. Remember that this is a vertical pipe here. It pipes it into my program so I don't have to type it every single time. Right? But did we get the correct answer? Yeah. Right? We should put this into we should do a lot more tests here. What's another thing that we should try here? What if you don't have any data? 1, 2, 3, 4, 5. You immediately kill the entire loop. What would you expect here? The average daily rainfall should be 0. Yeah. Nan? Not a number. Right? Why? No, you're dividing it by 0. Exactly. So, in that case, what would you do? You can't divide by 0 here. Check for 0 before you divide by it. If the number of days is equal to 0, I am not going to print out this. Instead, I'm only going to print it out if the number of days is non-negative. Printf. What should I print here instead? Average rainfall 0. All right. You gotta have something, man. All right. There we go. End the line. There. Run that again with 1, 2, 3, 4, 5. Yay. Gotta have something. And by the way, now that we're done debugging that, you can... Poor man's debugging, what you should do is you should comment it out, and then once you're done with everything, testing and such, then you come back and eliminate it entirely. Because if you just go ahead and eliminate it immediately and you're not done actually developing the program, you're going to come back and retype it at some point because you need to figure out what's going on there. Right? So I'm going to leave that there, and it worked, right? Yeah, you got to have something, man. All right. What else should we try here? What if they're all zeros? 0, 0, 0, 0. 1, 2, 3, 4, 5. That works. What else should we try? All negatives? -1, -1, -1, -2, -3. 1, 2, 3, 4, 5. Average rainfall is 0. You gotta have something. You didn't enter any dates. Yeah, go ahead. Oh, okay. 10. Yeah. What's it doing there? Well, scanf, it's F for a reason, right? It's formatted. If you refuse to follow the formatting, weird stuff like this happens, right? Now, if we were to do this on a test or on code post or something, we would not give you TEN, right? Because we're not expecting you to fix this. If you are interested in what the fix is, scanf actually returns a value, int num tokens matched, right? So if it matches this token, what it'll do is it'll return 1, right? If it's invalid, then it'll return 0. So I could add some code here. If num tokens matched, is 0, then what I'll do is I'll just quit entirely on them. Printf, please learn to type. There. I think that this will work. Let's find out. 10. Oh, okay. Please. And then what else do I need to do? Exit on them. Yeah. 1. There we go. Kill this, and then GCC a.out 10. Please learn to type. Right. But we're not expecting that at all. Because we only give good input as far as the input type. If you expect a number, we're not going to give you a non-number. Right? All right, let's clean this up. Let's get rid of that. Let's get rid of that. Right. There's probably a better way of doing this, but again, in engineering, what's better than good? Good enough, right? And then what? I should definitely change this up here. What's today? 9th, 12. And then it doesn't print hello world. That's another common problem we saw. People doing copy pasta, right? Copy pastas are you just copy and paste, but then that leads to spaghetti code, which is why we call it copy pasta. So this solves the classic rainfall problem. User enters rainfall until 9999, and then we tell them what the average is. Is there any other output here that would potentially be bad? We tried all negatives, we tried all positives, we tried all zeros. I think that pretty much covers it, right? Yeah. We could say like mash the keyboard, I guess. Right. And then 99999. What's going to happen there? Yeah, it'll actually end up working here, but no overflow or underflow technically because it's a double, right? So it's just that it's going to be accurate, but only out to 17 digits. And then at which point it becomes 972, blah, 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 right? So, and looks like the magnitude is way off too, but I could be wrong about that. All right. Any questions on the rainfall problem? Otherwise, those are the two basic ones that, I mean, the rainfall problem goes back to like the 70s. Right? It was used in exams and tests and stuff like that. Aptitude tests or whatever. Right? Let's see, that one's too hard. We kind of did that one already. That was your first hack. That one's too hard for now. That one, that's the one that you're doing this week. We're not going to do that. Crypto. A lot of them are going to be really, really mathy. Taylor series. I don't want to do Taylor series because I can't assume that everybody's gone through calc or anything like that. Some geometry stuff. Don't want that one either. You know what? Let's just do this one. Is prime. It's going to be mathy, but sorry. Like 5 to 10 years ago or something, somebody in my CS1 course commented, all of your problems are math. And I was like, what are you talking about? And I looked at the first homework. I said, this one was taken from business. It's a loan program. This one was taken from physics. It was a radioactive decay. This one was taken from something else. And I said, you know what we both realized together here? The entire world is what? Math. Right? So it doesn't matter what discipline you're in. Math is the foundation of everything. So let's go ahead and do this. I've already cut and pasted that, so that's good. What I want to do is I want to know if an integer, int n, is prime or not. I'll just go, well, here, I'll key, Wolfram Alpha. Give me a 5-digit prime number. Thank you. 12,647. 12,647. There we go. I want to determine if that's prime or not. Something is prime if the only divisors are 1 in itself. 2 is prime. 3, 5, 7. 4 is not prime because it's 2 times 2, right? Et cetera, et cetera. How do we determine if this is prime or not? Well, here, let me give you another value here. 42. Oh, no, that's too easy. 43. How do you know if 43 is a prime? Well, divided by 2. Does 2 go into 43 evenly? No. What's the next prime value? 3. Does 3 go into 43 evenly? No. Does 4? Well, you already tried 2, so 4 wouldn't go into it, but that's all right. We'll go ahead and keep trying. Does 5 go into 43? Nope. Does 6 go into 43? Nope. Does 7 go into 43? Do I need to keep going? Why not? What if there were a prime divisor greater than 7? Then it would match with one that's less than 7. Right? I don't have to go up even to, like, say, halfway, 21 or 22 or something like that. Why? What's the largest divisor that n could have? Well, 42 in that case, in the other case, right? But here, what about let's go with 49 here, right? Would be the square root of itself, right? So let's outline this. For each integer, and I won't bother with it only has to be primes. I won't bother that forget all evens or anything like that. I'll just say for each integer from 2 up to the square root of n, if, let me go ahead and call this d, for each integer d, if d divides n, then what would you output here? Is it prime or not? No, it's not prime. Output, not prime. Does anybody know what that's called? It's called a composite. There we go. All right. Otherwise, if you get through that entire for loop there, and you don't find anything that divides it, then what can you say? Output prime. Right? Okay. Now, I've outlined this. I've whiteboarded this. Now let's start translating it into C code. For each integer d, 2 up to the square root of n. I should have asked that. Should we use a for loop or a while loop? Well, naturally, I said for each, right? So clearly, it's going to be a for loop. For int d equals 2, d is less than or equal to the square root of n, because remember, 49, right? You have to go up to and including 7. D plus plus. Again, that's kind of inefficient because you can skip all the even values. You can skip 9, right? Because 9 is already a composite. We want simple code here for now. If d divides n, how do I do that? We did that yesterday with FizzBuzz. Is the number divisible by 3? Is it divisible by 5? Right? So if n mod d has a remainder of 0, then it divides it. Printf, not prime. Composite. There we go. End the line. Okay. Otherwise, you get done with all that, and what do? Print out is prime. There's still a problem here, but we'll solve it. Let's actually see if this works for now. GCC. Run this. Now, I asked Wolfram Alpha for a prime, so we'll find out if Wolfram Alpha is lying. Right? Hey, great. It's prime. Because it never found a divisor. If I went up just 1, it's already even. What should it output? That it's composite, that it's not prime, but not prime, not prime, not prime, not prime, not prime. Why does it do it more than once? And why is it outputting prime at the bottom here? Right. A whole bunch of stuff is dividing it, right? So more than one thing. In fact, probably nearly every even integer is probably dividing it. It's not prime composite. Let's add some more information here. Divisible by %d and the line. We'll say that it's divisible by d, right? And you'll see that this has a lot of divisors, right? It's divisible by 2. It's divisible by 3. It's divisible by 4. It's divisible by 6, etc., all those things, right? And then finally you say it's prime. I only need 1. Right? So the very first time that I see that prime, I'm going to stop. So here's a new keyword for you. You should not use it in general, though. What I'm going to do is I'm going to break out of this loop. Break out of the for loop. Right? And then come down right here. That will take care of all the repeated not primes, not primes, not primes, not primes. It'll only do it once, because it's divisible by 2, it breaks out of it almost immediately. But that doesn't solve this other problem down here of this being prime. So let's add another variable. Int is prime. And that's going to be either true or false. We'll set this equal to something initially. And then before I break out of that, is prime, well, is it prime at this point? It's not prime, so what should I do? Set it equal to 0, or better yet, I can bring in the standard Boolean library and create this into a bool, and then make this into false. Right? Then I'll break out of the loop, and then I can check if is prime, then I will output this. Okay. TCC. Oh yeah, I still have question marks up there. What should I initialize it to? Should I assume that it's prime until I find otherwise, or should I assume that it's not prime until I find out otherwise? I'm going to, so I find out otherwise is right here when it is not prime. So I'm going to assume that it's prime up front. True. Run that. There we go. Not prime, divisible by 2. Let me go back down to 7 to make sure that it still works for that one. Is prime. Right. All right. So give me a, do it something harder. Give me a 9-digit prime. All right. Thank you. It ends with 9, so it doesn't look prime, but it is. There, is prime. All right. Add 1 to it. 30. No, I don't want to do that. Let's see. So give me a 4-digit prime. Give me 2 4-digit primes. All right, thank you. And then I want to take those and multiply them together. Why is that a good test case right there? That's a non-prime number, but right? So it's going to say composite, but it's going to take a while to get there, right? It's not going to be immediately 2. If I just did, 18 on the first iteration of that, oh, it's divisible by 2, we're done, right? I want to make sure that I go all the way up as far as possible here to give it a real test, right? 8 out. Not prime, divisible by 3877. Was that one of them? I'm going to have to hit back. 3877 right there. And the other one is this one. All right, great. You can clean this up, but we're out of time so I'll go ahead and make sure that you've got this in the notes as well, and have a good weekend.